Good morning. Let us start. Before going into chemistry, important announcement. Starting from this Friday, we are having lectures also on Friday, 12:15, in this same room. This Friday, the lecture will certainly take place. The next Friday is still not clear. The next Thursday is 1st of May, which is public holiday. Next Friday has been given like as a free day, as a holiday, by the rector of the university. In principle, there's sort of no activities. I will need to check and do some thinking how much material we have left. If we can manage, we will not do on 2nd of May, Friday, 2nd of May, the lecture. But if I discover that we're really in trouble with time, then we will. So I will announce that either later this week or the next week. So I will let you know. But this Friday there is lecture. And now let us go to this calculation file. This was the thing that we worked with last time, but we did not finish. Who managed to finish at home? Almost everybody. Who did not manage to finish at home? Did you not try, or was it too difficult, or what was the... You have tried, but didn't really... Haven't tried. Did not try. Why not? Oh God. Okay. Okay, no big problem. Yeah. In any case, we will now try to solve this thing here in class. So, what we managed to do already last time was the average recovery and standard deviation of the mean recovery. And as you see from these blue arrows, thin blue arrows, these go into the component number 2. Into this component here. Component number 1 is 0, so with component number 1 we've already managed. And now we have these two last components still to take care of. The very last one is this one, this relative uncertainty of this factor. And this is quite a simple thing to calculate because its absolute uncertainty is here, and its value is here. So we simply divide one by the other. Equal to this one divided by this one. Well, and it's a good idea to put here the dollar signs, because then we can simply copy, because it's the same for all three analytes. Probably not difficult. If I go too fast or anything, you do not agree, shout immediately. Okay. Now, the relative uncertainty of solution analysis. This is this component with the minus sign. It turns out that this relative uncertainty we already have. It is relative here, so it already is standard deviation divided by concentration, this 2%. But it is the standard deviation of the single measurement. But we need here standard deviation of the mean, because we are right now characterizing a systematic effect. So we are trying to find the uncertainty of the mean recovery. So that, yes, we can use this value, but we have to divide by square root of 5. Then we get standard deviation of the mean. Equal to 1. 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 + 2 × 1 divided by SQ5. And again, it's a good idea to put here the dollar sign that we can copy. In this case, these values, as you see, are the same for all analytes, but this is not necessarily always the case. In your future calculations, you might have different Fs and different other things for different analytes. Now, finally, into these green cells, we have to assemble this whole thing here from beginning. Okay, I think it's okay if I jump back and forth. So equal to, then it is UR divided by R. So if we really want to have UR, we have to multiply by the R itself. Then we type SQRT. And now we go one by one. So this one comes from here. Oh, we take this one. Plus. Now we need this relative standard. Yeah, I forgot the square. Although it's 0, but let us still make all the calculation exactly as it should be, even if it wouldn't be 0, because in some other case it might not be 0. The next thing now is this SRW of recovery divided by the average recovery, and this is obviously the ratio between these two, so that we type parentheses. 1 divided by 1. And again, we put square. Okay. Now, the next thing is this with minus sign. And again, it has to be square, and it is located here. So we type minus sign, this thing. Now, the last thing is this relative uncertainty of matrix mismatch effect, which is sitting here in row 28. And this one comes with a plus. This one, square, and parenthesis. So I think it should be this. Yeah? We still need some dollar signs. Yeah, we will take care of those, but let me keep it for a moment here so that you all can see what it looks like right now. Okay, enter. Now I jump here and I put dollar sign in front of this C so that this would be taken from the same place. I saved, so it should already now be in Moodle. In case I was too fast, you want to see how I did. Let me put it here once more, yeah, so you can check if your calculation is the same. Any questions, anybody? If you think about it, it looks ugly. Not so difficult, actually. If you carefully see what are the different things and why they are there, it's not that bad. Yeah? Okay, let's make the copying operation. So 0.14, 0.14, 0.21, and let me maybe, just so that you could check your data, I'm putting here more decimals at the moment. So if all is correct, you should have exactly the same numbers. Anybody in trouble? Anybody lagging behind, not managing, too difficult? You have a mistake, don't understand where your mistake is? Whenever I press F2, everything else is eclipsed. So, yeah. Please raise your hand who managed to get the same numbers. Nikolai, Haider, how about you? Okay. Maitane, how about you? Parentheses. Okay. So there are two parentheses. Yeah, one is the SQRT parenthesis, and the other one is in the middle here. This recovery and its standard deviation of the mean. This parenthesis. Let me see. What is it?
I don't know why.
Oh, wait a minute. What is this?
But I don't know why sometimes it's number. No, but no, because when you drag it down, it will drag the
minus this. Maitane, I think B28 and B29 have been intermixed in your case. This UF is B28, but you have it at B29. If you exchange these two, then perhaps it will be correct.
Yeah, yeah, because
Oh, yeah. Now it works. Good. Yeah, mistake found. So now, having finished this example opens your way to a next homework. Yeah, I promised to say something about that homework. Yeah? So I will now remove those excess decimals and we'll save again. Now let me go to this homework. It's also nice to let you know that actually 4 people have managed to complete already that complex analysis homework. Maybe not that problematic and maybe not that bad. Okay. Okay. Yeah, here it is. Oh, it is. So this is the benzo A pyrene analysis, a carcinogenic polyaromatic substance. So here you have several things that you need to do. First of all, you have here calibration graph, meaning you have linear regression. No? Then you have spiking. Spiking you do exactly the same way as in this example. No? And then you have different other things here. Yeah, okay, this spiking uncertainty. Yeah, here the formula looks like this. Yeah? And yeah, yeah. Actually, that's interesting. The formula that you have is the right formula. I managed to replace, or I asked Irja to replace, but why is it? It's continue the last preview. This is why it is showing me still the old one. Let me put them. No? And now I will. Yeah. Yeah. Okay. Now I can go back here. Oh, now I should get right. Yeah. Oh, so here it is. Yeah. The old formula was not wrong in the sense that this is zero anyhow, but I wanted to have it exactly the same way as we have here in class, so that it would not be trouble. Yeah. So this F is here. Yeah. All the other things, you also need some volumetry, etc., some additional uncertainties, and so on. So all those things are here that you need. And now what makes it like, let's say, somewhat more difficult for you is that the model is not given. You have to figure out yourself. As you know, you have unlimited number of attempts. Not worry if it goes wrong. And also you're allowed to discuss between yourselves, but eventually all of you have to do yourself. So that you will need to, first of all, make a model where there's like slope and the intercept and then this, the average value of the sample signal, yeah, which you get from here. Then sample signal also has some other uncertainty sources. Yeah, you have to check that. You have sample mass here. You have some volume. So these masses and volumes somehow need to be like mixed into all of this. And then this whole thing is recovery corrected. So that you really need recovery uncertainty, so that eventually the overall uncertainty would be possible. And here it is sufficient if you just calculate combined standard uncertainties. You don't need to do any Welch-Satterthwaite or any of that. And here it explicitly says, find the BAT content of the sample, recovery correct. So if you have any questions now, please ask. I can then give you more information. With calibration graph also, it is explicitly said here what are the uncertainty sources of the signals and how the uncertainties of the concentrations are found. Should not be very difficult, I think. Now, column says, do we need to calculate uncertainty for individual sample replicates? No, column, you do not need to. You find the average BAP content, yeah, which you put here. And then, yeah, this is combined standard uncertainty of the recovery. But here you put the combined standard uncertainty of the BAP content. So you treat these three signals here as values of these three replicates. Obviously, repeatability is one source of uncertainty, which you know how to take care of. So, yes, it looks difficult, but good news, this is the most difficult homework. You will then still have two, which we haven't yet looked at. One is about data treatment of interlab comparison. The other one is about limit of detection calculation. Those are easier. This is the most difficult. By the way, let me check the general situation. Interesting. There are several people who have not yet done a single homework, even though there are three homeworks which already are completely known to you. You have all the knowledge needed. Yeah. Numerous people not yet finished a single homework. Very, very interesting. Let me remind you, homeworks are not at all obligatory. You are welcome not to do them. But for every unfinished homework at the exam, I will subtract one credit. And if you have, how is it now? 5 unfinished homeworks by the exam, then whatever your exam answer is, it will be an F. From A to B and C and D and E. Oh yeah, take care. Yeah, it's all up to you. You don't need to do homeworks for me. When the exam comes, I will simply, okay, 3 unfinished homeworks. Okay, your exam answer was A. You answered very well, but now I will take 3 points off, so it will be D. Yeah. If that is fine, you are welcome not to do any homework. Okay, I'm joking, of course. Please try to do, but then again, at some point the exam time comes, and then you have to have them done, because otherwise, very bad. Yeah. Now, is there a need for any other discussion regarding homework, this specific homework now, or can we move on with the slides? Of course, if you try and don't manage, the next lecture you can raise your hand and say, Ivo, can you still explain again? Because I really don't understand. Or if you have some specific. I'm not against explaining more, but the idea behind this difficult homework is that you would be able to build the model yourself. I think you should be perfectly able to do it. Not that difficult. So let us then go to the slides. We will stop recording for a moment and scroll to the right slide. Otherwise, it will be a huge number of slides in the recording. Will be inconvenient for you later. So we are now at the right slide. This was the last one that we discussed. I guess there's probably not much to explain more here, because we've now done this in the calculation. Anybody wants that I will explain anything here? Please say. Otherwise, let's move on. Okay. As I've said in the previous lectures already, there is no one single or no any strict boundary starting from which recoveries are unacceptable or starting from which they are acceptable. But there are, let's say, some quite often used like general considerations. So typically, above 90%, it's considered pretty good. And then there is really the question whether you should correct or not. Maybe you should, maybe not, yeah, depending on situation. Now, 75 to 90 is typically considered, let's call it tolerable. Yeah. People are not particularly happy with recovery 80%, but it is usually acceptable for most purposes. And correcting here might really be useful if you can. So the value will change markedly. And now recovery less than 75% is in many cases considered unacceptable. Essentially, you are asked to go back to the lab and improve the method. But there are situations when you really cannot really do much. I think this is also pretty clear. In different sectors and sectorial documents, like for example, maybe food, medicines, etc., there might be specific strict requirements. Okay, like if you want to do this analysis is in response to this legislation, your recovery must be at least 75%. Otherwise, your method is simply not acceptable. Yeah? And your analysis cannot be used to enforce that legislation. So sectorial rules might be. And now I'm coming to the next very important usage of certified reference materials, and this is checking whether your result is okay or not. In some sense, one could say this is even like sort of possibly the most important application if we speak about matrix certified reference material. This you can do either during the method development, method validation, but also during routine use. So it never hurts to check your method against the CRM. Also, certified reference material is most useful for assessing trueness, meaning that again you should do like more replicates usually than just one single replicate. But if you simply want to compare your individual result to a certified reference material reference value, then using something called zeta score is I would say, in my opinion, the best approach that you can. But what is very important here, before we look at how zeta score is found, is this last sentence here. If you did recovery correction, and if recovery was determined with a CRM, then you cannot use that CRM for checking your method. This would be something like trying to lift yourself from the earth by your hair, yeah. So you would essentially be like you will be checking with a CRM something that was obtained with the same CRM, which is not okay. So for that purpose, if you used CRM for determining recovery, then for checking how good your method now is, you have to use a different CRM. And this is quite a problem sometimes because you might not find the difference. Then you cannot really do, and you then most likely would be using interlaboratory comparison for checking your. Zeta score is calculated like this. So you take your result and the reference value. And this, although I have written here ref, and this is reference value, but zeta score is perfectly okay also for just comparing values of two different labs, of which neither is any reference laboratory. It can be your lab and your friend's lab, for example, if you both analyze the same sample. And here in denominator is the sum of squares of combined standard uncertainties, and square root is taken. Very, very easy to calculate. And why zeta score is good, it is in a way like a simplification, but what makes it easy to use is that you don't need coverage factor, you don't need Welch-Satterthwaite or any of that thing. So combined standard uncertainty is suitable, and in my opinion, for this purpose, it's very okay. Okay, and now you get your zeta score. How do you know whether you are good? Here is how you know. When the absolute value, you have to look at absolute value because zeta score has a sign. It can be positive or negative. If you look at absolute value and if it's 2 or lower, fine. If it is between 2 and 3, like a warning situation where it's not really not yet too bad, but also not really very good. And if it is 3 or above, then this is considered an unacceptable situation. It is considered a mismatch. So you did not, your result disagrees with it. And since, as we saw, CRMs also can have quite a bit of uncertainty. And if your method also has quite a bit of uncertainty, and if the zeta is still above 3, this means that although these uncertainties here will try to drag zeta absolute value down, then obviously your difference was quite substantial, so that the zeta value still is 3 or. So, any questions about this? I think it's very, very simple and understandable. And again, this can be used for comparing like any two values. The only requirement is that you have to have uncertainties for those values, or at least some kinds of estimates. If you don't have any uncertainties, the denominator will be 0, and then your zeta score will be infinitely high, and of course, like nonsense. You can, in principle, also calculate zeta score. For example, when your lab has uncertainty, but you don't know the reference uncertainty. If then you put here 0 instead of uncertainty of the reference, then you make this zeta score test very rigorous. And if then still you get zeta absolute value below 2, then you can be sure that you've done really well, because actually your zeta score is still smaller than what you got, because the reference value uncertainty is not 0. It's higher, but if you put here 0, you like artificially increase your zeta score. And if it still remains below 2, then it's very good. Why, for example, if you run some analysis and want to compare with literature, and if literature does not have any uncertainties, sadly is quite often the case, then in principle you can calculate. But then, of course, if you get above 2, then you just don't know whether you are the one who didn't really do well, or literature uncertainties may be big, and then it would be below 2. So you like don't have any conclusive. Now, this is the last slide. If I recall, some of you had some questions about finding CRMs, and I asked some of you to do some Comar searches, but I don't remember what they were. I think somebody wanted to see how prices correlate with uncertainties. Was it so? Who had that interest? Huh? Gleb. Okay, yeah, Gleb is missing. Okay. Yeah. I think Gleb is in military something, yeah, so like retraining or something. This is, I think, why he was also missing last week. So it's not because he's afraid of that I will be asking this question, but he has serious. But there was another thing. There was one more thing which I asked you to look at, but I don't remember what it was. Ah, yes. Okay. Yeah, I think it was so that, yes, the same matrix, the same analyte, but different concentration. Who tried? Did anybody try? Nobody. Okay, but then let us do a quick demo. Yeah. So I will then try to look at something myself. It will not be comprehensive, but at least I will show you something. Yeah. Oh, yeah. I need to share the. So let's see. Let's take something like imazalil, for example. This is a. Oh, by the way, can you remind me which pesticide exactly is the one that you do in your lab? So, it is imazalil. Yeah, okay. Well, that's like very appropriate. Yeah, for your lab. Yeah, maybe we could enhance the lab by buying the CRM for the lab. Yeah. Let's see what we can find. Okay, imazalil, and you see bad news. Just one. 1 out of 1 if you look here. Cucumber, but of course cucumber it's good, yeah, it's not so bad. Let's see what information we can get. Okay. Okay, here you see what are the property values, which pesticides are included. Yeah, imazalil here. Then I think if we go back, yes, this probably is the certificate. And the certificate is available. Okay, here you can also see what is the uncertainty of imazalil. If you look at, let me make slide. If you look at this, then this uncertainty is close to 10% relative. It's slightly less than 10%. I think 9% will it be if you divide 0.004 by 0.044. This is probably K2. Yeah. So that, yeah, not so small, but still it tells how this is. So it's dried cucumber participants. But don't see here the certification report. Okay, let's take something. Let's take lead, for example. Then we will get a huge number of certified reference. 251. Okay, yeah, that's many. Soil. Okay. 18. Also quite a bit quite a lot of different CRMs. Elements in sewage large. Possible. Okay. From this, from their own website, yes, you can get it. And certification report appearance. Yeah, now I need to. Sewage sludge is not exactly soil, but it is soil-like material. This is sewage sludge is something that is formed in wastewater treatment plants. Yeah, all this crap that precipitates on the bottom is called sewage sludge. And it is sometimes then trucked somewhere into the fields or somewhere because it's actually is very it's like very it's almost like a fertilizer. But the problem there is that oftentimes it contains some toxicants or heavy metals, which you cannot really use in agriculture, and then you cannot use the sewage sludge also. Okay, I will quickly run through. Yes, this seems to be at the same level of seriousness as the one that we looked already. You see all these between and within and stabilities and all those things that we've seen now also. So let me perhaps stop at this. I think you managed to find easily yourself. Yeah, you don't really need my my guidance here. And if anybody still wants, then you can try to take, for example, lead in soil and try to then see how uncertainty is linked to the price or price to uncertainty, and also what different levels of lead in soil can be found. I think there were 18 CRMs which came up if you put lead and soil. They are not all soil. As I said, sewage sludge, not exactly soil, but it's sufficiently similar to soil by what it is, so that you can put it all in like in one comparison. If anybody is willing to do this, we'll be very happy, and we will then, or we can then discuss it next time. So, but now we've come to the end of certified reference materials. Any questions about certified reference materials before we move on? Apparently not. Okay, certified reference materials, I think, was not very difficult thing, understanding-wise. It's pretty easy. And the next one will also not be very difficult understanding-wise. And this will be interlaboratory comparisons. So here I'm Sorry that I only this morning managed to finally update the slides, so that you received them very late, but hopefully that's still acceptable, and at least at the moment they are nicely downloadable in Moodle. So interlaboratory comparisons are the second big tool besides reference materials that we will be looking in this section. And again, there are numerous different guidance materials and standards according to which interlaboratory comparisons are these days usually carried out. Like this ISO 17024 is standard according to which interlab comparison providers, or more specifically proficiency test providers, can be accredited. So if you want to organize proficiency tests in an accredited manner, you can have yourself accredited according to this standard. It's in a way similar to the ISO 17025, which I think almost all of you know very well, as this was the quality system lectures, one of the topics. Definition-wise, interlaboratory comparison is organization, performance, and very importantly, statistical evaluation of results of tests. And by the word test, it can be chemical measurement, physical measurement, or some really like technological tests, some hardness or tensile strength or whatever kinds of thing. All kinds of things can be run, all measurements and testings can be run as interlaboratory comparisons on the same items. So sometimes interlab comparisons are run in such a way that the same thing travels between laboratories. Everybody gets the same item. This, of course, means that the item must not be consumed during the intercomparison. For example, in mass measurement or length measurement, some metal blocks are sent around, so every lab receives in sequence and they do their measurements and then send on. The same or similar test items. And in chemistry, we, with a very large majority of cases, operate with similar test items, because test items are consumed during analysis. So not one bottle is sent around between labs, but every lab gets individual bottle or several bottles and does the analysis. Obviously, those bottles need to be indeed as similar as possible, preferably, ideally, identical. By two or more laboratories, so yes, you can do interlab comparison even with just two laboratories. And it's oftentimes called bilateral interlaboratory. And also important in accordance with predetermined conditions. So interlab comparison always must have predetermined rules, which are then observed and not changed midway. Very important. And we will see how this thing works. And of course, we will mostly focus on chemistry, on interlaboratory comparisons. Now, in somewhat simplified way, we can see 4 different types of interlaboratory comparisons according to the objectives. So the purposes, the objectives of interlaboratory comparisons. Maybe even the most important in metrology is for establishing traceability. So traceability always means that something is compared against something, although it is nowadays oftentimes like said that this is like a calibration that traceability is based on. But calibration also is comparing like your instrument to a reference instrument or your sample to a reference sample. That traceability part will be the last part of this course. So that in this lecture, we are not going to look at establishing traceability. That will come later on. Then, very important things are these 2. Number 2 we actually already looked at. Yeah. So we've already seen how useful and important is interlaboratory comparison for certification of reference materials. But we will revisit it here a little bit, very shortly, yeah, later on. Then, those of you who are from the EACH program and take our EACH seminar, you have already been also exposed to interlab comparison for validation. There was the TransFATS method, yeah, which was validated by interlaboratory comparison. And you had some examples of that. But here in this course, we also will look at that. Yeah? So we will, but both 2 and 3, we will touch upon quite briefly. Because for a routine laboratory, this is number 1, proficiency testing is the most important one, yeah, besides traceability, yeah, which is a separate. So it is quite often so that if you work in some kind of lab, you actively participate only in proficiency tests and not really in any other intercomparisons at all. Because traceability in chemistry oftentimes comes in such a way that you do not actively participate, in fact, in an interlaboratory comparison. I will explain that later. So that for the most time of this intercomparison lecture, we will be looking at proficiency. About 90% of our time will go to proficiency. And the other intercomparisons, we mostly compare what are the main big differences from proficiency testing. And then we go to proficiency testing. So this interlaboratory comparison is an interlaboratory comparison with the aim to assess the competence of laboratories. Labs want to know how good they are. Accreditors want to know how good labs are. And customers also want to know how good labs are. The best way, if you are some lab person or lab head of the laboratory, the best way you can prove to your customers that you are good is you show interlaboratory comparison results. See, our lab is here. We are in very good agreement. That's the best thing you can do. And also accreditation actually requires that. I think those of you who took quality systems last semester, I guess probably Arlo explained this to you comprehensively. This is very, very important. Now, you could always say, hey, wait a minute. Is it really necessary to participate in interlaboratory? I can buy a CRM and check if my result matches the CRM. That's good, right? It almost is. Yes, if you compare yourself with the CRM, or your value with the CRM, sort of as good. But here is an important detail. Proficiency test is an independent activity. Let me explain what that means, and let me explain why accreditors so much want that you participate in interlaboratory comparison. They're not really satisfied if you just analyze CRM. Suppose you buy a CRM and do the analysis and you see, I'm off. Well, let's forget about that result. Yeah, let me just try to do again. Yeah, I will now do this better and that better. Yeah, until you finally get the good result. Oh, and now you go and show to the customer just the best one that maybe you 3 times you failed miserably, catastrophic. Yeah, but one time you got it right. In intercomparison, you cannot do that. I have no idea what the right result is. But I forgot to mention, whenever you get the CRM, you have the certificate, you see what you have. So that even during the analysis, you might already, my result tends to be on the low side. Let's eliminate these low-level replicates. Oh, no, it's slightly better. All that I'm right now showing is absolutely forbidden way of acting in a laboratory, so don't do that. Yeah, but sometimes people do, and this is very humane, I would say. So humans are humans. Yeah, but in interlab comparison, you have no idea what the right result. You simply send your result, and then you get back the results of everybody, and you have no way of changing anything. If you are off, you are off. Secondly, as we just found, like imazalil, very important pesticide, we had one single CRM. Suppose this year you compare yourself to that CRM, but what do you do next year? Again, the same CRM? So good if you always use the same one. So you cannot run regularly checking your method with CRMs so that you would have every year a different CRM, because there are no CRMs. Yeah? But in many proficiency testing schemes, new round is organized every year. So you can participate every year. Every year the sample will be different. Yeah, this year it's orange, next year it's cucumber, next year it's tomato, etc. Or suppose if it's drinking water, okay, then this year it's drinking water, next year it's drinking. But it's always different. This year much lead, next year not so much lead, a lot of cadmium, so much of cadmium, no, a lot of magnesium, then not so much magnesium, etc. Yeah? So that proficiency testing is much better suited to see that you are doing well regularly. And although it's not usually like strict requirement, but my advice would be that with every method that you use in your lab, if you are a routine laboratory, if possible, you should participate in intercomparisons once a year. Would be very nice. More frequently, maybe it would be already like too much additional workload, but once a year, I think is very okay. This is the best thing you can do to convince your customers. Then when customer comes in, you show, okay, here are our results from interlaboratory comparison from the last 7 years. See, everywhere we are. I cannot imagine a better and more convincing way to tell accreditor, customer, whoever, that you are good than showing this. Okay. Now, as I said already, proficiency tests are often organized regularly, and they are called proficiency testing schemes. I already mentioned that you should participate regularly. Nice frequency is once a year. Yeah, proficiency testing scheme. Sometimes PTS is used. And an individual intercomparison in a PT scheme is called round. This year's round and next year's round, and then so on. And many benefits. First of all, laboratories can assess their competence on regular basis, and as I said already, this is required actually also by the accreditors. And organizers also will gain long-term experience. Yeah? We will come later on to the requirements. To the organizer. And it turns out that actually it is very good if organizer has a lot of experience in organizing. And now here on this slide and on the next slides, I have like a stepwise list how a proficiency test works, or actually how a round of a proficiency test works. I'm not going to explain here everything or read all this. I'm going to just say some things. We have for most of these items separate slides later on. But let's see, Christian is asking, why is it that clinic or bioanalytical labs term their interlab as EQA? Is there difference between EQA, ET, or others? This EQA, can you tell me? I've heard this term, but evaluation of quality. What is EQA? If you write it down, let me, while you are typing, let me say that no, there is no principal difference. EQA is also the same thing as proficiency testing. Proficiency testing is any intercomparison where the, okay, yeah, external, yeah, good. Proficiency testing is any such intercomparison where you want to test how good the laboratory is, and this is the same thing as external quality testing. So no difference and no problem that they call it that way. So now, first of all comes preparation phase, and this is what organizer does. Yeah, choosing the organizer, establishing objectives, defining matrix and analyte, preparing the test material, and preparing the samples. Up to here. Then stability and homogeneity of the samples has to be determined. Then, and here you can notice that I have put it in italics. In some cases, at this stage, also reference values are determined. But in some cases, reference values are based on the results of participants, and then they are not determined at this. I will explain that also later. And then choosing the participants. Now, that was preparatory phase. Now comes execution phase. Samples are distributed to participants. Participants receive the samples, yeah, and store and do all the manipulations that are needed, yeah, and then carry out the analysis and report results to the organizer. And then phase 3 is now again by the organizer. So the organizer carries out data analysis. We also will look at here. And then makes conclusions, summarizes everything, and creates a report and sends it back to us. And now item number 4, or big section number 4, which oftentimes is not listed separately. It is application of corrective measures by the participants. Meaning that if participants receive the results and they say, we are off, then they should not just leave it like that. They should try to find out where they went wrong. I wanted to bring this specifically in because this is very important. Actually, it's also required by the quality management systems, so that whenever you find that something is wrong, you have to do something about it. Yeah, not just leave it. So these are the main steps, and we will now look more in more detail at each of them. But before, maybe you have questions. Yeah, take the microphone.
Just about these actions, if that it's a required to participate in an accredited lab, but if you show up poorly results, what does that mean? Like they're gonna or like that is gonna be the...
Yeah, this question is asked, I think, on most editions of this course. Somebody asks exactly what you asked, and this is a very, very reasonable thing to ask. Indeed, what happens if you are completely off? Will you immediately lose your accreditation? It might depend on your area. So in some areas, it might be really very strict and serious. But generally, and now I'm speaking for, let's say, the Estonian Accreditation Agency, which is the, or Estonian Accreditation Center, as it is called officially, which is the accreditation body here in Estonia. And their logic is that no, they are not taking your accreditation immediately away. let's say, okay, you participated now in interlaboratory comparison. Your z-score was 6, for example. Yeah? We will later see what z-score is if you don't know, but 6 is very bad, very, very, very bad. Yeah. Then the assessor comes, yeah, okay, this method within accreditation scope, okay, did you participate to interlab comparison? Yes, I did participate. This is our result. It is not really a good result. Usually they say, okay, but what is now your corrective action? What have you done now to rectify this? And then what they actually want to see is that, okay, you checked what can be wrong. Maybe your sample preparation is not good enough, analyte is not separated, you lose a lot of analyte. Maybe it's contamination, maybe it's interference. The equipment well maintained, people, are they well trained? Maybe it was a fault of a person who was simply very young and not yet experienced. Then you have to send that person to the training or do something. So you have to demonstrate that you did something. Then usually, at least here in the Estonian Accreditation Center, then what the Estonian Accreditation Center typically does is that they give you some deadline by which you need to do those corrective actions. And if you do them and show, okay, we now did it, then they are sort of happy, but then they, of course, ask that, okay, but now, please go now and participate again in that intercomparison, and let's see how good you are now. So one such result which is strongly off is not usually a big problem. But of course, if it persists, then it is not good. Why they do that? There's actually I think a very good reason why they don't want to be very strict, why they don't want to take accreditation away. You see, if you are suppose you are this drinking water lab and you have contracts with drinking water companies. Drinking water companies are obliged to have their drinking water analyzed by accredited lab. You have contracts with all of them, and suddenly you lose accreditation. You lose all your income because they cannot have your analysis then. Because it will not useless. They cannot show to anybody that they have done it in an accredited lab if you have lost accreditation. This means that it will be catastrophic for the lab. And the Estonian Accreditation Center is absolutely not interested that labs would go bankrupt or out of business. But there's a second thing. If it would be that strict that if it happens, lab will go bankrupt, then this would invoke a very strong incentive to make all kinds of like data manipulation, fraud, hiding information, all kinds of things. Okay, we participated, but let's say we did not participate at all, and so on. And that's actually much worse. So that, and this I think is a very, very right, that in all these quality management things, usually honesty is very much encouraged. It's very much encouraged that you never hide any mistakes, that you always show all your mistakes, but then in return, you can expect understanding, yeah, and that you will not be immediately like beaten down, but you will not immediately lose your accreditation. I would say that just getting it wrong in an intercomparison is in a way, in their eyes, might be even not as bad thing as if they find some real fraud. Then they really can take away the. But if it's a honest mistake, then usually it's. But again, I'm now speaking about a very general situation. There might be sectors when it is not so. Aitane, did I answer?
I have another question. I'm not sure about how who is the organizer, like real life, like it's like there's like an association of labs that say let's do this because we need it. There's like the company of water testing. Is it the government? It's just like I don't understand how it works. Like or all of them can organize inter-laboratory comparisons.
I will put this here for myself, that I would perhaps make a small slide about it. I will answer immediately.
Or even for the accreditation of ISO 17025, it's required to do these comparisons, or it's like some kind of international association who organizing that also.
Yeah. You gave several examples. Is it this or this or this? And I can say it can be any of those. There are companies that do that as a business. Then laboratory organizations indeed organize proficiency testing for their members. And then governments also can do that. Usually it's not really government office that organizes, because they don't really have the expertise for that. But there are governmental labs. And here in Europe, there is such a system that there are something that is called CRL, Community Reference Laboratory. And this means that in different countries, there are in certain sectors, like appointed reference laboratories, whose task is to guide other laboratories, help them to validate methods and help them to develop methods and see how good they are. And also, among other things, they organize intercomparisons. But for example, in analysis of environmental waters in Estonia, there's as far as I know, I guess it's still true that the lab where Riin Rebane works in, which is Estonia Environmental Research Center, is the reference lab here in Estonia for, like, let's say, river water, lake water, etc., all that kind of water analysis. And they do organize intercomparisons. And then there are reference laboratories for pesticides and then so on and so on. So that, yes, it's numerous bodies that can organize intercomparisons. In principle, anybody can. We have done that. And I'm going to demonstrate some of our interlaboratory comparison documents as we go. I'm going to illustrate some of those things that I'm going to tell you with the documents from our own interlaboratory comparison. We are not doing that actively now, but we used to do it for quite some years. Did I answer? Now I see Christian has a question. The minimum number of participants for a PT round for it to proceed as number of labs affect the consensus value. I guess the different organizers may have defined a minimum number. But there is no, I don't think there is such a thing as some, let's say, overall official minimum number which applies to all different intercomparisons. Those that are run as business usually manage to attract tens, sometimes hundreds of participants per round, so that the number of participants is not an issue at all. Then there are some more, how would I put it? let's say, less common intercomparisons where there are maybe not so many participants, but those sometimes have independent reference values. And if you have independent reference value, then the number of participants is not really a big problem at all or big issue, because the reference value is then completely independent of participant data. I will explain what independent reference value is and what consensus value is. Christian, are you happy with my answer? Okay. Any other? Apparently not. Okay. Then here in Moodle 3.2 is one set of documents of one of the proficiency testing round that we organized in the past. It's now already years ago, but it's still fully relevant, so the year number does not really matter much. And those documents that you find there, I will also use here as examples to illustrate. And then in our testing center Katsekoda website, you also can get some general overview what intercomparisons have been organized over the. And now most of the headings on the slides have these numbers that we just had in the steps, so that we can keep track of where we are. So first of all, most those proficiency testing schemes are like well established, regularly organized. So then, of course, new organizer is not chosen every time. Yeah, objectives are not redefined every time, etc. So as I already mentioned, organizers can be very different, and objective essentially is to test or to find out if laboratories in some field or some type of sample analysis are good, which means that the objective essentially contains what samples and what analytes. The samples and analytes. And again, if it is like drinking water intercomparison system, then every year it's drinking water. And the question is simply that, okay, this year there's more lead and there's less lead, or if it is some fruit and vegetable intercomparison, then of course every year there can be different fruit and vegetable. This year it's apple, and next year it's banana, and then it's plum, and then it's peach, and Now, having said that, there are lots of different possibilities who can be the organizer. It's important to add that the organizer has to really have the expertise required for this kind of thing. The organizer has to have administrative capacity, because there's a lot of emailing back and forth and preparing documents and so on. And also like mathematical statistical ability that perhaps goes into the competence. And of course, it is good if the organizer has long-term experience. It is also good if the organizer has laboratory facilities, so that the organizer can prepare the samples or prepare the material, distribute it into samples, check stability, and so on. But that is not an absolute requirement. So that it can also be simply an office that organizes proficiency tests, so that the sample preparation can be outsourced. I'm not saying it's preferable. Preferable is that the organizer has like hands-on in sample preparation also, but it is not so critical. But the organizer certainly has to have very good understanding of all the aspects of intercomparison. Now, preparing samples And here we can go quite fast because it's very similar to preparing certified reference material. Perhaps I can already now ask you that, what do you think are the main differences from preparing certified reference material? I've already actually mentioned, I think, on one of the lectures, one key difference. Exactly. You don't need to test for long-term stability. There's no need that the samples would be stable for 10 years. Samples are stable for 1 month, it's usually more than okay. And this is also one of the reasons why you find proficiency tests with more diverse analyte matrix combinations than CRMs, because in proficiency tests, you don't need to have that long-term stability. And second difference is that usually you don't have to have so big number of samples. Usually you don't need thousands. Oftentimes it's sufficient if you have tens, let's say many tens, oftentimes. But with producing CRMs, many tens is almost never sufficient. You'll have to have at least many hundreds. And here you see the same things come up, yeah? The individual labs must have identical samples, identical matrices, yeah? Maximum possible homogeneity, yeah? So the same way as CRM bottles must be as similar as possible. Also, the samples of proficiency testing must be as similar as possible. And then again, exactly the same. Everything has to be processed in one batch, then divided into the samples. There's always some variability, but variability has to be smaller than it is expected that the participants will have. So that if there's small between bottle variabilities, but participant variability probably will be like this, then the small between bottle variability can be. This I actually already answered, but let me just stress that here also you have to have a lot more samples than you have participants. Because you need to test sample-to-sample variability, short-term stability, and you always should keep spare samples because some of them might get lost when sending or might arrive broken. All kinds of things can happen. So you have to have spares so that you can resend them. And here again, exactly the same as it was. There are two main ways. You can do formulation or real material. And again, formulation is possible with only very limited number of very simple matrices. So most of the time people use real. So I think again, unless anybody wants to ask, I think I don't need to repeat, yeah, because this is all we've already seen. And this is also, again, very, very similar. Variability of analyte concentration between samples. This is essentially as serious as with certified reference materials, but stability is less serious in the sense that you do not need to determine long-term stability. Short-term stability. And how these things are determined technically is the same way as with certified reference. There's no difference. Yeah. Okay. And now we are coming to something that is really different. In certified reference materials, of course, the producer has to certify them or organize certification so that they will have reference values. But in intercomparisons, proficiency testing, not necessarily. So that, reference values in very broad terms can be of two types. Independent, which means they are not dependent on participant data. They are determined by reference laboratories who are not participants, like gurus, experts, or by formulation. Formulation again means that you weigh some amount of ultra-pure water, you add some salts, carefully weigh the amount, mix well, and then you have water where you exactly know how much of this or that or whatever ion is inside. What is formulation? And independent reference values, of course, are very good because they are highly reliable, they have uncertainties and traceability and everything. But, of course, they are usually expensive and take time. So that, in fact, the big majority of interlab comparisons do not have independent reference. Which means that the reference values are actually determined from the results of participants. And this is now again, which simplifies very much proficiency test organization as opposed to CRM production. Because the organizer does not really need to determine how much of any analyte is inside. Participants do it for them. And such reference values oftentimes are called consensus values. So independent reference values and consensus values. And if the values are, or reference values are consensus values, determined from results of participants, then obviously they are not determined beforehand. They will be known only afterwards, when participants have submitted the data. These values typically have lower reliability. They don't have rigorous uncertainty statement. They don't have rigorous traceability, but it's inexpensive and fast for the organizer. And this inexpensive is also very important because labs also try to look out for cheap intercomparisons, not for expensive ones. But if there are independent reference values, expert labs really want quite some money for their work. It's not just some chemical analysis. It's a very important analysis. So it's not so cheap. It takes time. So it makes everything more expensive. So that organizers typically are quite happy with tens or maybe hundreds of participants, because then statistically it's like a big number of participants. And getting a consensus value from 100 participants is very okay, actually. You can get, usually, with some exceptions, I'll have some examples here also. Usually you will get fairly good consensus. So it cannot really be said that having consensus value from participant results is something very, very, very bad. This is very opinion-based, what I'm going to say now, but in my opinion, it is much better to have more variety, more diverse availability of more cheap and simple intercomparisons, which have consensus values, rather than we have very few intercomparisons, much less diversity, but then there are very good independent reference values from expert labs. It's rather better that labs have more possibility to participate, even if the reference values are consensus. And this is exactly how it works right now. As I said, most of the time, with few exceptions, reference values these days of proficiency tests are consensus. So it's 11:45, These examples, I'd like to give some more explanation than I can give here in 1 minute. So I will explain these things next time, which is tomorrow. But today, unless some last minute questions. session. We close. Thank you.